dictionaries. And we saw that they do what? They store data in different forms. So they are different. Let me share my screen maybe for the three. Okay. Sorry. I hope you can see this amazing screen. So before we go to today's topic, I want us to look into not looking. So yesterday we saw lists. We saw lists, and we saw dictionaries. Right? We saw that a list, if I have my list, how do I declare it? I say my list equal to, I put square brackets, and I put the content here. If it's a text, I put it inside quotes. If it's a number, I put it just like a number. It can also be a dictionary. You can store a dictionary as a list. Yesterday we saw it. You can store dictionaries in a list. This is real data. For instance, you have clinics. You can write a clinics list. You can write a clinics, list, and then in the clinics you do what? You inside the list you add dictionaries which identify that clinic. That is the name, the ID, and all data related to that clinic. We also saw dictionary. I'm sorry, I think this is. We also saw dictionaries. Dictionaries store data in key and values. Let me share the whole screen so that I stop using this. Okay. I trust you can see my screen. We saw dictionaries store in key value order with a key and its value. Those are dictionaries. Okay. But those are not the only data structures that we have that store data. There are many, many, many data structures. We have what we call a set. Okay? Sets store data. Sets are immutable. Yesterday we saw that the dictionaries at least are mutable, which means you can change elements inside there. But sets and what we call tuples are immutable, which means you cannot come and change it. So when you need a list where you won't need to change them, you can declare it as a set or a tuple. We cannot cover all the data structures here. We have so many data structures. Maybe to show you a hint, let me just Google and say data structures in Python. So the four list, tuple sets, and dictionaries. This is what I was telling you. Okay. A list, the syntax is here. We saw it. Is it ordered? Yes. Mutable? Yes. It can be changed. Unique elements only? No. Okay. A tuple, ordered? Yes. Is it mutable? No, you cannot change it. Okay. Unique elements only? No. But a set allows only unique elements. You cannot, in a set, you cannot add two numbers that are equal. No. Okay? It's used in data application and mathematical operations, right? So there are a lot, these are the main, but there are a lot more other data structures which you can build on top of Python, but these are the ones that are inherent to Python. These Python already knows them. So you can read more about the other two data structures that we did not cover. You can see lists, plus all these are called methods or functions. What they do, we saw append, we did not see extend, we saw insert, we saw remove, we saw pop, okay? But it has more, you can do a lot with a list, okay? This is the official documentation. You can use it to write, to understand things, okay? There's also code. You can read about what nested compressions, list compressions are, like creating a matrix in math. Those who do math, you use nested list compressions. You can transpose a list, which is a matrix, for those who are in math, okay? So I wanted to show you that although we cover these things, there are things that we do not cover in detail because we are just doing an introduction. But if you are, for instance, in data science, you deal with a lot of math. People like Colette who have a math background, you can do math in Python, using matrices. How do you do a matrix is by declaring a list, what we call a nested list, which is a list that has lists inside. Okay, you can multiply matrices, you can transpose them. So when you do data science, you use all these data structures. You use lists, you use tuples, you use dictionaries, right? So you can always read. So unfortunately, we do not have enough time to cover everything in detail, but you have a solid background. You can go and read more about these ones. Okay, I don't know if I'm the only one who is not hearing you well, or everyone else hears me except you, right? Okay. Yeah, please read about more about those data structures, how they can be used. And we'll do a project where we'll try to at least, but if I bring a matrix today, people would be confused. It's not like everyone has to do matrices. So when you're learning Python, it has, like on the first day I told you, it has different applications. But if you want to apply it in data science, you will be using matrices in data science and math. If it's for web development or something else, you won't need to write matrices. If it's just for data analytics, you won't need a lot of matrices as a data analyst, but you will need to understand all of them because you need to store data. Okay, so that was just a few verbals for about what we covered yesterday. So let's turn to today. What are we going to look in today? So today we are going to see how do you make decisions using Python and what we call loops. How do you iterate? So every data structure, when you're dealing with them, you just don't come here and write it and then that's all. You use it, okay? If you have a list, for instance, if you have a list called list A, eh? List A, okay? declared like this. Okay, you have elements here in list A. Okay, first of all, you need to take decisions about that list. How? You can do conditions. Okay, what we call conditions. A list, take a list or a dictionary as a table. Let's make it simple and say maybe we have a table which is form sort of a dictionary. If you're a table like we're doing in SQL, you might have maybe 01, 02. These are the keys and the values are, let's say, A, B. If you want to query your table in Python, you can say, I want to run through this table, assume it's a big table, but when, like we used case, here we use if. Okay? If the ID is maybe 2, which is B, what do I do? Maybe if it's a girl, I do this. If it's a boy, I do that. Depending. So when you're taking decisions, you put if statements. Okay? So maybe if it's 02, the ID, maybe I skip it. Okay? When you skip in Python, you say just continue. You're skipping it. Maybe you're not interested in product B. Okay? So how do you skip that? You just write an if. Or let's say you have a set of numbers, 1 up to 10. And you want to do what? You want to have just even numbers. Let's create set list E of just even numbers from that set. How do you do it? There are a lot, there are a lot of ways you can do that, but one of the ways is you check in that list what we call iterating. Iterating a list or anything is moving through that list, coming from here up to the end. That is iterating. So what you do is you iterate this list and say, whenever you see, how do you check an even number? An even number is a number which is divisible by 2 in math, okay? So how do you check that? You say, I will look for numbers where you remember the operation we used to check remainder. So that is, if I get that number A in that list, divide it by 2, the remainder should be 0. Okay? So if you want even numbers, you will write a condition and say if that element in set A, in list A, when you divide A, that element A by 2, you get 0. Then get that number. That is an even number. Okay, get it, store it somewhere else, maybe as a list. So the condition is the decision. Okay, the loops is how do you iterate? Because you have 1, you will be checking, you come and say, okay, 1 is 1 divisible by 2. You take 1, divide by 2, you find it's not 0, you skip it. You go to the second element here, you check, is A, which is 2, divide by 2, yes, you keep it as an even number, like that, okay? So the way you iterate through that list, you use what we call loops, okay? So in other words, loops is performing an action that is repetitive. That is repetitive. From this example, this pen is not cooperative. From this, you can see it repeats. From this example, what is repeating? This operation, A percentage 2, which is any number divided by 2 equal to 0, it is repeating. So you need to loop over that list and then be doing this condition. So that means loops and decision making go hand in hand. Okay, So you teach here today, we want to teach our programs to choose with if and to repeat with for. So we have different types of loops. Eh? There is a way of looping them. So when you combine a decision and a loop, you do what? You get the data that you want depending on the condition that you have. Okay. So let's first go with how do we take decisions. First, we'll do if to take decisions. There's a if or else. That is done a girl. If not a girl, maybe is a boy. So else, just like in English. Okay? That is if clauses. Okay. Then we combine conditions with and or all. So these operations when we started on the first day. Then we loop over a list with for. There are other types of loops. There are mainly three, but the most common ones are two. What is called for loop and a while loop. And a while. Okay. While loop. That is while A is divisible by 2, then do something. It continues to iterate. Then we will combine loops and if to filter and count elements in a data structure. Okay? So let's first do if, else, or elif. Okay? If is a comparison. Okay? Here, let's take it as in English. Okay? When you say, let's see here, temperature. This is our variable called temperature. Okay? Is 24. Now we want to know, is today a hot day? Is it hot today? Is it warm or it's cool? And we have conditions. We have that what is a hot day? You define what is a hot day. A hot day is a day where the temperature is greater than 30. A warm day is a day in which the temperature is greater than 20. So a cool day is less than 20. So if you have temperatures maybe 0 to 10 to 20, you'll excuse my pen. I don't know why it's behaving like 20, then 30, and maybe 40 plus. So then you will say, okay, if maybe this is my thermometer, you record with your thermometer and store your value, write your value on a paper called temperature. That is a variable. Then how do you check? From 0 to 20 here. This is what? This is cool. It's cool from 0 to 20. From between 20 and 30, it is warm. It's just warm. Maybe you have all that information. Then after 30, kuzamura up to wherever, it is a hot day. Indeed, it is a hot day. Okay. Now you want to know, is this a hot day or what? You want to tell your program to tell you, is today a hot day or what? So use if. You say if temperature, this in our case, temperature is 24. So according to this condition, the temperature of 24, is it cool, warm, or hot? Anyone can answer.
It's warm.
It is warm. Why? Because it is is it greater than 20? Yes. So we have warm and hot. But is it greater than 30? No. So it's now warm. Okay. So you write your program. How do you write it? You say if, the temperature is greater than 30. So if statements, when an if statement, you write an if statement, after the if statement or the condition, you do what? You write these two dots. So what you're telling Python with these two dots is, okay, I am inside this condition, this if. I'm inside this condition. So that is why you can see, observe well, there is a space here, which means this is called indentation. You leave space, you go inside the condition. After that, you come outside that condition and say, elif, that is else if temperature is greater than 20, is a warm day. Else, so that is other than that, it is a cool day. You print. We know how to print. So how does it behave? It comes and checks this variable. It's 20. It starts from up. It checks. Is 24. It gets this value because it's the one in temperature. Is 24 greater than 30? No. If it's no, it skips this inside this condition, this content inside. So it goes to the next condition. Now, is 24 greater than 20? Yes. So because it's already greater than 20 and it's not greater than 30, it doesn't go down here. It doesn't. It just stops from here and says it is a warm day. You get? So if we had something like, let's say we have 10 as our temperature. Okay? So it comes and it asks, if you've written this program, it will come and say, is 10 greater than 30? No. Then skip, continue. Is 10 greater than 20? No. So else, that means if it's not greater than 30 and it's not greater than 20, it must be a cool day. So it comes here and prints cool day. You get? You get? So in writing if conditions, you just write, the syntax is you write if, okay? If your variable, then condition. After that condition, you put these two dots to tell it that now I'm inside here. Then you count 4 spaces. Python knows it. When you do tab, you do 4 spaces. Then you are inside this if. If this condition fails, you go to elif. That is another alternative. Like that, like that, like that. Okay. Do we understand the logic of if statements in Python? Okay. Any questions so far? So you can combine if statements with, so this is the only condition. You might have more than, maybe you have 2 variables. You say if the temperature is 24, but that is not the only variable you are seeing, and maybe it is raining. Is it raining? Maybe we say rain, and instead of being a number, we call it a Boolean. You remember Boolean. Boolean is true or false. The Boolean data type, okay? It is either true or false. So we say, is raining? We say maybe true. Let's say 1. So we say that if it's raining, it is 1. If it's not, it is 0. Okay? So for the condition for to be a hot day, we want that it is greater than 30 and it is not raining. Because if it's 30 but it's raining, let's assume that's not a hot day. So you can come here and add another condition. We say and, okay, and it is not raining, so rain is equal to 0. And rain is equal to 0. Okay, so it must pass these two conditions for it to be a hot day. You get? So you can also add another condition here. So with this, there is something maybe we didn't touch on the first day on operators. In these operators, maybe you forgot. Did I tell you these two? Because we did greater than, I don't remember. But this is equal, okay? If I say A equal B, and A is, I put two equals signs, okay? These two are different. Can someone tell me the difference? Anyone? Just guess. Eh? Just guess. These two are totally different. You have one and this. So I've said this because in most cases, everywhere, when you're doing conditions, you'll be using two equal signs so that you do not get confused. Because if you use one, you will do wonders. Eh? So who can tell us what these two, what's the difference between these two in Python? You can even Google search. Tell me.
You mean there's two operations?
Yeah, the difference between these two operations in Python.
I think the first means that we are equalizing A and B. We are taking the value of B to be in A. And the second means that we are testing if A is equal to B. Yeah, this second operation is logical operation, and the first operation is assign.
This first is an assignment operator, right? Okay. While this is a logical or comparison operator. You said it well, thank you. Okay. So what it means is A, when you have a variable A, you have something like a box in your computer, and you have another box in your computer called B. Maybe in B we have 3, and in A we have 2, okay? So A, B. You get? So if I say A equal to B, what will be the value of A? If I say A equal to B, what will happen? Anyone? What will happen if I do this and then I do this? What will happen in these two? This is very important because when we enter into conditions, you must understand the difference between this and this. Can anyone tell me what will happen if we do this?
Okay, if B is not defined, then it will be an error because it will say B is not known. if B is not defined, if we don't know the value of B, then
Here we have in A, this A variable, we have 2. In B, we have 3. So we are doing A equal to B. What will be the output?
the output of A will be 3, the value of B.
The value of B. That means it's like, okay, how is it like? It is like you're telling Python, come, this is A, eh? Copy this value in B and put it here. Okay, so if you print A, it will be 3. It will be like B. Good. Now, how about here? If I print A equal B, what will the value be? The output. Anyone?
Yes, it's like you are comparing the value of A and B. So 2, then it will be false. 2 and 3 are not equal.
It will be false. Nice. That means if I have A and B, A is equal to 2 and B is equal to 3, right? So if this is comparing, it will give me a Boolean, true or false. But this one will just copy the value of B into A. Let me show you a vivid example. A real example here. Sorry. Let me create a new file. Sorry. Let's open today's folder. Okay, let me create a new file for let me say pushup.py. Okay. So what I will do, let me say A equal to 2, B equal to, no, actually, let me rename this into a notebook.
You'll need to unlock your iPhone first.
Let me do a notebook. Let me create a new notebook, okay? And we say A equal to 2 and B equal to 3. Okay? Let's print A. I know what it's trying to tell me. Let me create a test environment. So it's creating, I'm just creating a new environment to run. A. It's delaying, sorry. Okay, so let's print A. Let's say A equal to A, okay, and B equal to B, right? A equal to 2, B equal to 3, right? Now let's do what? Let's do A equal to B, and then we print A. What will be the output of A? Anyone? Here, what will be the output? Here, A is 2. We have a variable A called 2. We have a variable B called 3. If we print A equal to A, you can see A equal to 2, B equal to 3. Now here, let's print A, okay? A equal to A. What will be the output here? If we run, you can see A is equal to 3. Yet here it was B, it was 2. We have swapped, no, we have copied the value of B in A. If we print B, B equal to B, okay, it will also be 3. You see, but here A was 2. So if you do this operation here, you're copying A into B. Now let's do print A equal to B. What will be the output? And also here, let me first write it. Print A equal to B. What will be the output of this print? A is 2, B is 3. Print A, print B, then print A. What will be the output of this line? I want us to talk.
It will be an error, I think.
To be an error? Why?
Because earlier we were learning this and you said A 2 cannot be equal to 3.
Okay. Will it do an error? Because, okay, yeah, that 2 is not equal to 3, right? It can't. But this is comparing. It's just comparing, and it does an output. Of course, they are not equal. So what happens if they are not equal? The role of these two is just comparing. That means when you compare, you do what? You provide a value. So this is basically saying, is A equal to B? Okay. If yes, then say true. If no, say false. Now, what is the value here? This is what we're basically saying. We were asking Python, is A equal to B? Are they the same?
It will give a false.
So what will be the output? Was that Ella? It will give a, let's see, it's a false, correct? Now let's copy here the same code and write it here. What will be the output here? We've said A equal to B, print A, print B. Now the same code. What will be the output? Anyone? Anyone? Continue. Who was speaking? Who was speaking? Tell us.
I was the one speaking, but repeat the question.
So here we have this code. We have A equal to 2, 3, B equal to 3. We printed A, we printed B, we printed A equal we compared A and B. Now I want to know the output of this. If we run this code now,
Code B is equal to B.
this one. So this is compare. You know A is equal to B. I want us to know the difference between a single equal and double equals.
Okay. A double equal will give you either true or false. So in that case, it will give us false.
It will give us false. Why? Here. So here it gives us false,
Because it's
right?
comparing, okay?
Is it a false or a true?
No, for me, I see the condition will give us true
Why?
because the condition said that A will be equal to B.
Where? Oh, you mean, so here we are asking, is A equal to B? If yes, true. If no, false.
Yeah, for me, I think it will be yes. Yeah,
So that
it is
means
equal
A
to
is equal to B.
yes.
True. Why has it changed?
Because on first here on first condition, you said we mentioned the value of A and the value of B. But on this condition, you say that A will be A, which is equal to B, which means that the value of A, it will be equal to the value of B.
Exactly. Yeah, that's true. So here I had A equal to 2 and B equal to 3. In
Yes.
comparing them, it gave us false because they are not equal. But here I came and said, now get the value of B and assign it to A.
Yes.
So that means they are equal.
Yes.
This is the comparison. Now, if we are doing if and we are comparing, don't use here, use this one. Unless you want to know that if A is equal to B, then print A, B, right? So for instance, if I say, if A equal to B, print equal, but A is equal to 0 and B equal to 1. No. I would be looping. I don't want to loop here. Okay, now you understand these two. The difference here is assigning. Okay, here is you're comparing. So you cannot say like this I had written. If A equal to B, you can see there is an error. But if I do this, the error disappears because you cannot say if A, I put B in A. Okay. So back to our slides. Okay. So that is the if. So the else is the condition where if is false, like here. Okay. Then else is when the condition fails everywhere. So let's see where you can also combine conditions, different conditions. For instance, like I had shown you here that if we change our definition of hot and we say the temperature must be greater than 30 and also it must be raining. That is rain equal to 1 or equal to true. That is when you are combining conditions, which is here on this slide. Okay. So when you're saying maybe age is 25 and has an ID, that means for you to vote, you must be of age 25. Okay. And no, for you to vote, you must be of age 18 and above, and you must also have an ID. Now this person called X comes and registers, and we find they have age 25 and they also have an ID. Will they vote? The condition for voting is you must be 18 years plus. So you must be 18 years. Sorry, let me correct this.
I'm not sure what you're trying to edit.
Okay. You must be 18 years plus, but you must also have an ID. Now my age is 25 and I have an ID. I come to the ballot office. Will I be able to vote? Will this person be able to vote? I want to hear.
Yes.
Yes, I will be able to vote because I am 25 and I have an ID. What if I have an ID? What if I am 25, which is above 18, but I do not have ID? Will I vote?
No, you
This
cannot
person.
vote.
Yeah. Okay. So this is exactly what it's checking. It comes and says, okay, this person called Fiona is 25 and has an ID. You come here. Is her age greater than or equal to, is 25 greater than or equal to 18? Yes. After that, it comes here. And do they have an ID? Yes. Then it prints can register to vote. If it comes and says she has 25, does she have an ID? No. This one will fail because of the and. You remember, for and both must be true. If it fails, it will skip this and automatically says you cannot register. You see? Okay, so we are going to read it aloud. Going to read it loud and Okay, so that you see how Python is written in sort of English. I'm going to read it loud and you hear. So I have age 25 and I have an ID. So if my age is greater than 18 and I have an ID, I can vote. Else, that is if any of these fail, I cannot vote. Okay. So the and makes sense. Okay. Now, so you understand the condition, the if conditions, before we go to loops. Do we understand the if conditions?
We do.
We don't?
We do.
We do. Yeah. So for now, we want to do, we are going to go for another concept of iterating through a list for now, but they can be used in, can be used anywhere. So what is a loop? A loop is, you remember, if you do a looping, like around something, this is a loop. Okay? You get? Also, if I have a list of elements, what does looping mean in English? Let me look for what looping. A loop is the shape made when a long thin like string or curves around and crosses over, crosses over. So you're looping around something, okay? Let's say in computer. What does a loop mean in computer? A loop is a building block that tells the computer to repeat itself, a set of instructions over and over again until a specific stop condition is made. So you must have, it runs over and again until something tells it, okay, stop. You get? You get? So there's a for loop, while loop. This was the other thing that I didn't want to mention here. Then infinite loop, this is an error. We'll see what causes infinite loop, and why it is important to know. So a loop, when you're looping, you're telling maybe you have a list, but we don't loop list only. We loop elements where there are a lot of elements. So we have a country called a list called countries. We have Rwanda, Uganda, Kenya. Okay, what does looping through this list mean? It means I come from the first element, the second, and the third. Okay, so looping is looping around. So how do you do that? You say we are using for loop. So we say a for loop runs its body once per item in a list. It runs, gets to Rwanda, stops. Not stops, like immediately goes to Uganda, then to Kenya. Okay? You get? So let me show you how you write a for loop. You write for keyword. You remember what keywords mean. So you write for. For what? You give it a variable. You can say for country or anything, for I or for X. But for now, because our list is countries, we say for any country. For any country, that is one country in in a set of countries. You can see here. Let me know. For country, in countries. So this is the variable you give it, you give any. So this is open, it changes. This variable changes because it says for country in countries. Then you also close with these dots. Then enter inside the loop, you say hello country. So here you're greeting the country. You do what you want to do. You get? Let's write something code for you to understand. Let's say countries. Okay, we have these 4 countries. Now I want to say, to loop over the countries. Okay, and say for country in countries, loop country. So this, how does this happen? I have a list of countries, then I say for any country in countries, print that country. So this 4 comes and says country in countries. So this in tells it go to this countries list, and then the country is the first element. So it finds Rwanda. After finding the first element, it comes here and prints that country. Then it goes back, okay? It goes back and then finds Uganda. When you find Uganda, that means the country is Uganda, okay? Then Kenya, then Tanzania. Once the list stops, it does what? It stops. Let me run and you see. Can you see? Maybe printing, wait, writing, country, number, then I say countries, yeah. So let me show you how it works. You see, it's saying writing country number 1. The first country is Rwanda. You remember I said dot index country plus 1. You remember, can someone guess why I've added 1? Okay, I've added 1 for me to count. You see this hashtag? I wanted it to start from 1. Hashtag 1, hashtag 2, eh? So you remember indexes in list start from 0. If I do this, it will start counting from 0. You see? But that's not what I wanted. I just wanted to show how it runs. So for the first iteration through this list, it comes and gets the first country, which is Rwanda. Then it prints Rwanda. That is country. You can see it is changing. This variable is changing. After that, it goes back to the list and sees Uganda. Then says writing country number 2, which is Uganda. I can now, let me say variable country is now set to country for you to see how it is changing. Eh? Now writing country number 1, variable country is now set to Rwanda. It has changed. Writing country 2, variable country is now set to Uganda. So this variable you're saying is now changing. So that is the beauty of loops. It helps you iterate over a list of things. If you have 1,000 list things, it just loops. Let me show you another example that we have in the slide. Let's do random numbers. Eh? Let's say for I in range, okay. Sorry, I want to print I.
An eye is a sensory organ that allows an organism to perceive visual information. Want to hear more?
Okay, so what does this mean? It says for I in range 10, This is a new function, but you can read about it. Okay. This range, how does it do? It says range, stop, it return another. So what it does is, if I do 10 here, it returns from 0 to 9, like in Python. So you can count a random number, or let's say if we do 1,000 and we do a loop for I in range, this is 10,000, it will be printing up to 10,000, you see? So that is how loops work, okay? But sometimes you can have what they call here, if you do Google search, there's what you call an infinite loop. An infinite loop is a mistake, okay? Maybe people are on your website and they click something, it loads, and then until the server crashes. How is it done? It is where a stop condition is never met, eh? You see? So you write accidentally a condition because a for loop, a loop stops after a certain condition. For instance, here, Rwanda, Uganda, Kenya, Tanzania, the condition is it is looking into here, this list. If everything is covered, it just stops. Now let me show you something. Let me try to do an infinite loop. For country in countries, let me delete this and print country. Then I'll be printing country. After printing that country, I print it and say if country is equal to unknown. Okay. Then country not found. Okay. But we can, let me just say pass. Pass means just stop. But do you think this will stop? I'm saying stop the loop if the country is unknown. Okay. How does this work? It says it. So as I had told you, this for loop goes to country, then to this list countries. It looks for one country, the other, the other, the other. So let me maybe first show you what this pass means. If we say Kenya, if we say Kenya, what will happen? It will loop. When it reaches to Kenya, the loop stops. Rwanda, Uganda. Let me check if it's well written. Rwanda, print. Oh, it is, okay. This is supposed to go on before printing. Okay. For country in countries, if country is equal to Kenya, pass, else print country. I was using the wrong word. Keyword. Yeah, I was using the wrong keyword. Instead of break, I used pass. So you can see it comes and here and says Rwanda, Uganda. If it goes to Kenya, it finds Kenya, it checks this variable country is Kenya. If it's Kenya, it just breaks the loop and it stops. Now let me show you what an infinite loop is. An infinite loop is it tries to run and then the condition is never met. Let's say X country, maybe Somalia. Is Somalia in this list? No. But you are putting a condition. No, this will also stop. Yeah, it will also stop because there is no Somali. I want to build an infinite loop. Let me show you. I want to build an infinite loop. So what an infinite loop that is it just, well, it's actually not even good to try that because it runs and runs. I'm trying to use this list to see how I can create an infinite loop. Okay, this works. While sorry, I want to. Yeah, this will return. Okay. Let me do 10. I see. It's out of range. Yeah, I'm failing to write an infinite loop which does not stop. Let me do this. So you can see, exactly. Yeah, sorry. So you can see this program will run until it crashes. Why? Let me stop. I'm saying while this variable is one, this variable is equal to one. While it's true, that is, it's one, print count, then count equal to what this means is count equal to count plus one. But I have not added a condition where it will stop or when. I said while this is true, while this is one, is one, comes here, prints one, okay? Then it gets count, gets 1 plus 1 equals to 2. Then it goes back here to 2. It continues to 3 to 4. It never stops. So these kind of loops happen when you will see when you do exercises with loops, you will find where you run an infinite loop because you've forgotten to add a condition when it will stop. Okay. So this is important to know. You might not understand it like right now. It's a bit complicated, but once you run something, especially when you're doing with loops, and it doesn't stop, you can see it can run up to billions and billions. Then know that that is an infinite loop, and know that you have not added a condition for it to stop. Okay, so a condition to stop is if count is greater than 10. So we want to stop from 10, just break the loop and stop. So this will stop from 10. So loops are very important in iterating over a list or a dictionary or anything that has a lot of elements in it. Okay, so also we can now count and filter loops. Okay, using that is combining a loop and an if statement. Okay, let's assume you have a list of patients. Okay, you have a list of patients. Okay, then you have today you received maybe is a list of patients where you record attendance every day, right? Today you recorded 34 patients, tomorrow 51, the other day 42, 66, 21, 71. Okay, so now you want to know, sorry, now so you want to know which are busy days, okay, and which are less busy days, okay, and then you add them. You add, maybe this is a monthly list of attendance. Then you say, here you write total. When you're combining, you keep, like I had kept count. So why do you keep this total? Because you will see in the loop here, it is changing. Okay, let's say total and then busy days. We want to know the total of days. When we add, we want to know how many busy days. Here we are counting, here we are doing sum. So for P in patients, we come and iterate. So every patient here, so the P is 34, 51, 42, 66, 29, and 70. Total, so we do the total. The total is total plus P. What does this mean? When you're counting in loops, here you are starting with 0. So the first iteration, if we say for loop I, let me write something. Okay, so here for the first iteration is, it comes here and say this is total is 0, busy days 1, 0. Okay, so for P in patients, what are you telling Python? You're telling it that go to this list and loop over the list. Okay, so for the first iteration, for the first run, P will be what? Who can tell me? P will be what? When the program first runs, what will be the value of P here? It is looping in patients.
It will be 34.
It will be 30. Sorry, this to be 34. Now, when P is 34, what will be the total here? So it comes, the way Python runs, it runs like this. So it comes, P is 34. Then what is the total? Here, total will be 0, because total, we gave it 0. So 0 plus P, which is 34. Okay, so the total here will be, sorry, the total here will be 34 on the first run. Okay, then you come down to if P is greater than 50. Is P greater than 50? No, so P is 34 here. Is still 34. Is P greater than 50? No. So if it's no, this condition will fail and the program will go to another P. So there is no else. That means we just want to have the busy days only. So if P is great, so what will be the value of busy days now? If P is P greater than 50? No. So when it's this condition, that means this condition will fail. When it fails, it will not reach here. It will immediately stop. So busy days will still be 0. So here we have total of 34. And busy days, we have 0 busy days. Because our definition of busy days here is they must be greater than 50. Okay? Good. Now it finishes the first iteration. It goes to the second P. The second P now here is, let me use this side. The second P now is 51. Okay? P is 51. The total is 34. So it comes back here on top. It says, okay, the next element is 51. It stores P as 51. It comes total equal to total plus P. That is 34 plus 51. Okay? So the total will be 85. Total will be, okay, let me write. Total here will be 85. Okay? When P is 51, total will be 85. Now it comes here. Is P greater than 50? Because P is 51. Yes, it is greater than 50. Now we get busy days. Now see here, we don't add P. We add 1 because we are counting. So that means busy days was 0 because this condition is passing. P is greater than 51. It will add a 1. When you're counting, you add a 1. So that means it will be 0 plus 1, which is 1 busy day. We are counting busy days. We have 1 busy day. Okay? Then we go back, so it completes. It comes here and completes. We go to the next P. The next P is 42. So total will be 42 plus 85. So new total will be, what is 42 plus 85? This is 127, right? Am I correct? Are you following? Is someone following or chance subiremo ntangire? Should I start again?
We are
We are
following.
following. We are following.
Okay. At this point, T total is 124, the total number of days, because it is now we are getting 51 plus 34 plus 51 plus 42 on the third iteration. Third iteration. Now P here is 42 in patients. Total will be total plus P, which is this 127. Then it comes here in this condition. If P now is 42. Is P greater than 50? No. When no, it won't come here. So the busy days will not be added because the program will not reach here. The condition has failed. Instead of reaching here, it goes back to the list. Then P becomes 66. When we do 66, it comes, total will be, so total we still have here 127, busy days 1. Okay. Then total will be total. The total we had was 127 plus P. The new P is 66. So what is 127 plus 66? We will have a new total of, this is 13,193, right? As a total. Then it comes here, it checks this condition. Is 66 greater than 50? Yes. It comes now, it continues down here. Busy days, we had 1. Now, because it has passed, it comes here and says, okay, busy 1, because it has passed, busy 1, go to busy days, go to busy days and add 1. So busy days will be 2. You will add 2 because it is the second time it has passed. Now the program completes, we go to the next element, is 29. It comes here, it gets the total, it adds on P. P is 29. So the total will be 193 plus 29. So 193 plus 29, it will be 291, 292. What is 193 plus 29?
222.
220? 222. This will be the total. Then it comes down here, it compares P, which is 29, to 50. Is P greater than 50? No. It skips this, it goes back. So busy days will continue being 2. Then it checks 71. Okay. It comes here and adds on the total. P now is 71. Add 222 to 71. What will be total? The total will be
293.
right? 293. Okay, so total has become 293. We are here. Then it comes and checks if P is 71. Is 71 greater than 50? Yes. So that means we will need to go down and update busy days. In busy days, we had 2. Now we are adding 1. Why are we adding 1? Because whenever P is greater than 50, the code says we just add 1 because we are counting. Instead of adding P, we add 1. So then we have 3. We have 3 here as busy days. Then it finishes, it goes back, it finds the list is completed. When it finds the list is completed, it exists and gives you the result. That is why here the total is 293 and busy days is 3. This means you had 3 busy days. When you treated 293 patients, you had in those 293 patients, only 3 days you were so busy because you had over 50 patients. Do we understand how now the flow works here? That is how it counts. So if you have a larger list, that is, it counts until a certain condition. Here the condition is iterate through the list. You can also say iterate if the number of patients is greater than 100, just stop. Don't look for other patients. It stops. So that is the logic. We have exceeded the break time by 6. Yes, someone has a question. Yes, Jonah.
Yes. My question is, can you repeat again with the what makes that syntax stop, that loop?
Okay. Yeah, good question. So the loop iterates, it iterates until, because there is no other condition here that stops it, after this, it will iterate until it completes this list. So when P is 71, it will come and take total plus 71. It compares 71 with 50. Because 71 passes this condition, it goes here. After it goes here, it adds 1 to the busy days, then it tries to go back here. Once it tries to go back here, it is intelligent. It will look for anything here in the list. It finds that I have done everything here, then it automatically stops.
So you mean it cannot return back to the first one, the 34?
No. Unless you program
put
it to
anything.
do that. No. So for this, what we've written, that is exactly how it works. It will stop when 70, unless you program it to, but now you would be creating an infinite loop. It will continue looping.
That's what I was thinking. If you have no maybe a statement that say after 71 you have to stop, so it continue going back to 34 to 51 or again and again and again.
No, it is intelligent unless you explicitly say something. It will be because it is based on, it is looping through patients. For P in patient, what this is the statement. As long as we have P in patients, we iterate. After we complete the whole list, we basically stop. Okay? So you cannot create an infinite loop there.
Yeah, sure.
Okay. So let's take a pause. Then let's see what's happening. Yeah, it will be the end for the slides. Okay. Now, let's take 10 minutes. So we've stopped at 7:40. Let's come back at 7:50 and we go to the push-ups. Yeah, let's look at the exercises for today. So we've seen how to make decisions and repeating work. It's basically what we've been doing. Okay, this is the code that we run, right? Okay, so if you run this, so here you can see we have temperature of 24. Okay. Why is it not running? We have a temperature of 24. Then so you are stating, okay, if the temperature is greater than 30, you will print a hot day. Elif temperature is, so elif is used between, if you have more than one condition, then else is used later, like after. You cannot, there's if, elif. If you also have another condition, you would come and here, like you would come here and write elif, maybe temperature is greater than 10, print cool day, maybe this is cold. You can see elif is used between if and else. I don't know why. Still loading the environment. Okay. So I'll be passing through these. We have looked into them. Then I'll be skipping the exercises. As usual, someone else will come and take over from you. Today I'll choose someone randomly. Everyone be ready except Colette. Yesterday, I won't pick you, Colette. Okay, so let me wait for this to. Okay, so you can see if temperature is greater than 30, we will be printing. So if I do this, you can see if you do like this, it shows an error. What you do is just click tab. So tab by default, it gives you 4 spaces, or you can write 1, 2, 3, 4 spaces. That is indentation. Otherwise, it won't know. So make sure in every condition, something that belongs inside that condition, you must write it under the condition. Otherwise, you will face so many logical errors. Why? Some conditions will be running, but giving you poor, incorrect answers. I'm waiting for my virtual environment to allow me to run. Okay, meanwhile, I can copy it here. And so you can see it prints this is a warm day. Why? Because the temperature is greater than 20. Okay, but it's not greater than 30. You see? We all understand this code now. Okay. So let's go back to the example here. I skipped the exercise. Now we wanna do what? We want to combine these conditions. Okay. When you're combining conditions, now we had only one condition here, that temperature must be greater than 30 or 20, but now it's not about the age. It's not about one variable. It's more than one variable. Okay. So if you have the age of 18 and above and you have an ID, you can register to vote. Otherwise, so that means whether if any of these fails, you cannot register. For instance, let's do false. Okay, you cannot register because you are above 18, but okay. Now let me show you something. What if I say all? What if I do all? Then run. You can register to vote. Okay, but if I say I am 10, notice what happens. It still allows me to vote even when I am 10. Why? Can someone tell me how is this thing working? Anyone?
Just because or said that at least one must be true.
Exactly. At least one must be true. So this is false, but this is true. But if they all become false, that is when I will not be allowed to vote. If it's like this. By the way, let me ask you, if I do like this, what will happen? You see? Let me do and. You see, even if I am 29, you can register. So this thing, you can see I've confused it because when I say has ID, okay, without anything, maybe bingo has ID equal to 2, equal to 2, okay? But when I say just, when you see that has ID, this is a Boolean. It is either true or false. When you say has something, or something but without a variable here, okay? For instance, if I say a variable name and then equal to, I say equal to false. Okay. As long as you have and, you must have name like this. That means you need to be above 18, let's say 24, like we used to have. Then you need to let's set this to true, like it was. But we've added another condition that you must have a name recorded. Okay. So if we run it, it will say cannot register. Why? Because you have no name. You can't register without a name, and we've added it here. But if we say it's true here, that means you fulfill all the conditions and you are eligible to vote. So you can add as many conditions as you can here. Okay. So let's try to play around with this. Okay. I'm going to say A. Okay. Even numbers. okay, equal to, let me do for A, even, for even in range, let's do 100. 1 if even is, so this is what we call compression. Compression, okay? If I print even number, so this, you can see you can use a for loop inside a list, okay? Let me print even number. What does this, okay, let me do 11, okay? What will be the output? The output will be a list of even numbers between 1 and 10, okay? So how does this do? You remember range here. It takes the numbers from 0. Okay, I started from 1, okay? So if I did like this, I would also have 0 included. You see? So let's say we have range up to 10. Okay? Okay, let me do this. Then you see if even is greater. You remember this, even is, so you remember this percent sign. It says you get, so even you go in this range, okay? After you go in this range, you say 1, it iterates, so it starts from 1. Then it goes like this, a variable, it comes here, so 1, like we were doing last time, it's 1. If, so is 1, when you divide 1 and 2, do you get 0 as a remainder? You remember this operation. This operation says get even this variable, divide by 2 and check the remainder. If the remainder is 0, so this gives the remainder. So here, if I is 1, if even is 1, you get a remainder of, which is not 0, it skips 1. Okay? Then it goes to 2 using this range. Okay? When it goes to 2, it comes and checks, is 2 divided by 2 the remainder 0? Yes, it records 2. It goes to 3. Eh? Is 3 remainder 2 0? No. So it's not. Similar thing would be, let's say, you can also say even numbers, I initiate a list, an empty list. Okay, then I say for I in range, you see, these are the same. So, okay, I'm saying even numbers, I created an empty list. This is also a list. You can see this is a list. So I create an empty list. Then I create a for loop, which is also this one. So you can see list comprehension. Okay, this is called comprehension. This comprehension is a way of organizing lists and if. But if we follow the current order, you declare even numbers, an empty list, then you loop here for I in range. Remember, range takes from 1 to 11, so to 8 to 10. Then you say if I, so you count I in range like we are counting. So the first time I is 1, it comes here and checks, is I remainder 2 0? No. When it finds that this is a no, it doesn't go here. It just goes back here. Yeah? So if it checks, it goes to 2 because this gives you the numbers 2, 11 to 10. So if, so is 2 remainder 2 0? Yes. If yes, it comes here. You remember what this does from yesterday's lesson. You get even numbers, which is a list, and then you print, you append, you add 2. So instead, so if I print even numbers, you will see it's the same like this one. So I'm going to show you how they increment. I'll say print I, okay? And also print even numbers. So how we want to see how it increments, okay? You see? So here I'm adding this loop, okay? Inside this loop. So why am I adding this inside this loop? Every time it will continue running. But notice this one, let me call it final list. Okay, I call it final list. For it, it will come here after everything. Okay, after everything is complete, because it is out of the for loop. You see, the for loop checks these conditions. After everything is finished, it now goes to this print. Okay, let me show you how it goes. You see, even number found. No, let me first print even numbers. Okay. Now let me do this. So what you will see how it is incrementing. So for range here, the range is 1, 2, 3, 4 up to 10. This is what it means. Then we come here. For I in range, I is any variable. As I told you, it is dynamic. It changes depending on the number. So how does it work? It comes and say I is 1. It comes here. If 1 divided by 2, remainder 0. Is that correct? No, the remainder is not 0. It doesn't go here. Okay? That is why you see even number found 2. There is no 1. Then it goes back to the list, to this range. It gets I as 2. Then it comes here and checks. Is 2 divided by 2 remainder 0? Yes, we know that yes. If it's yes, it comes and prints even numbers, which is a list. For now, it's still empty. We have not added anything. This is why it checks. But it says even number. Let me run. So it first prints the list of even numbers. Here it is empty because we haven't added anything. It again shows even, but we have found an even number, which is 2. I is now 2. Then after that, we do what? We get even numbers and append 2 to the list. Okay? Now we finish. You can see we are not printing the final list here because it is out of the loop. Okay? Then it goes back. It gets 3. Okay? Then it comes here in if. Is 3 divided by 2 equal to 0? Remainder 0? No. Because it's a no, it skips everything here. It goes back here to 4. Is 4? Then it comes here. I is 4. Is 4 percentage 2 equal to 0? Yes, the remainder is 0. If it's 0, print 4. No, print the list of even numbers, which was having 2 here. It only has 2. We have not yet added 4. Then, but we found the even number, which is 4. Okay? We can even say print end of end of ith 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 iteration. Okay? Okay. Of course, the first, the second will be second, but it's okay, the English. So you can see the first iteration is complete. Okay. So we found an even number 4. Then we append 4 to the list. Now we go to number 5. I is 5 divided by 2. Remainder 0? No. It doesn't reach here. That's why it skips. You see, we have the 4th iteration. The 3rd iteration, we don't reach there because it did not reach here. Okay? Then you go to 6. Is 6 divided by 2 remainder 0? Yes. Then we print even number found, which is 6. Then we end the iteration and we append. This should be, you see how it follows. Then it reaches 10. Is 10? Yes, it comes here. That is the 10th iteration. After that, it prints now the final list. You can see it prints this one later, okay, of the list of even numbers because it is outside the loop. Let me show you if I put it inside the loop, what will happen? Who can guess what will happen if I put it here inside this loop? What will happen if I put this final list inside the loop? You don't necessarily need to tell us the output. You can tell us what will be happening.
It's going to print the final list every time.
Excellent. Every time for every iteration, it will be printing the final list, which you don't want. So you can see finalist 2, finalist 24, finalist 246, finalist, you see? But that is not what we want. We want the final list. We want it after everything is done. So this is what you can do. But there's what we call list comprehension. Instead of writing the whole of this, when you master this, you can just come and do this. You can see it's the same output. But we have how many lines of code here? 1, 2, 3, 4, 5. Here we have just 2 lines. You see? But you understand now how the for loops iterates. Right? Okay. Let's go back to the exercise. I hope, yeah, this is, we saw this, the loops country. Okay. We saw this filtering. Okay. Maybe you can again run it through this. Okay. Let's also see how this works. The logic. Okay? Once you master the logic, you will. So let's see so we have a list called daily patients. Okay, we saw this. You remember how it was adding. Okay? So what will be happening here? What will be happening here is we already have busy days and we are counting the total of the patients. Okay, so for the first iteration, we have 34. So patient in daily patients. Daily patient is here. We get total plus patients. So you see, total starts from 0 and count starts from count busy days. Then, but when you do busy days, you add 1. You are just counting, you're not adding. So it iterates and then checks. For every iteration, it checks if the number of patients is 50. Then where the number of patients is 50, that is a busy day. You then add 2 to the number of busy days. Okay. I hope this we try, we still remember it, right? Okay, so I'm going to who is willing? I know Colette has been doing so many push-ups here. Who can share their screen and continue? Do the exercises here. Before I pick you, I'll pick you. Who can volunteer to do that? Nobody? Okay. Let me. Bobo, can you share your screen and you walk us through these exercises? Can you? You people, you don't want to, eh? Okay, Colette, are you ready? Can you, you know, when you're sharing your screen, you're the number one beneficiary.
So let me, I am not sure about my internet today, but we can try.
Yeah.
Okay, so
Please, I want us to, our goal is for everyone to participate. If you feel you aren't able to participate, but when you share your screen, we challenge you, and you also challenge yourself. But it's okay, Colette, you can, if you're ready.
No, let me try this time. Let me try.
Okay, no worries. Colette, let him share.
Share screen. One second.
Please, others, when they share the screen, it's all our work. We need to collaborate with them. It's not like they're doing it alone.
And can you see my screen?
Yes.
Okay, so I think what we need to do is this exercise 3.4. The list is the list is a variable called scores. So scores is equal to 45, 78, 88, 52, 95, 33, and 60, which means that it has 1, 2, 3, 4, 5, 6, 7, 7 items. So the first question is to count how many students passed, which means that the score might be greater than 50. So how many students passed? So we are going first of all to create a variable. create a variable that is going to store that number. So we'll create the variable to store the number of students successful students of successful students. So I will call this variable, for example, the student students who passed. Yeah, okay. Students, I can put underscore pass. So this is, and I will put it to 0 because we will start looping, and once we loop, I think if it's greater than 50, we are going to add 1. So I can just copy the for loop here. Okay, let me just write the for loop for let me say score in scores. I think you understand what I mean by from score in scores, because those are score. Let me just say student score in scores. Those are student scores, and then from there I will write if student score is greater than 50. Then we are going to count. So student pass equal to student pass plus 1. What does it mean? It means that if the score is greater, so you update this number. For example, for 45, because it's less, it's not going to enter the if loop, and not the if loop, but the if condition. And for 78, because 78 is greater than 50, so it's going to update the student pass to 1. So it's going to add plus 1. So, and it is going to do the same iteration every time. So as you can see here, I think we are familiar with these spaces. So when you are in a space that is inside another space, it means that you are inside the. If for example, if we have a space between, we have this space here, it means that if is inside the for, and the student here is inside the if. So we have to go out to print the final result. To go out and print the final result, we have to go out of the for loop, for example here, and then we print the result, like how many students are, how many students passed. So the second thing also, we will do the F. This is the how many students passed. How total number of student of successful students. All right. So, and we put the total that is supposed to be student pass. So if we print this, as you can see, I try to loop the for loop and the if condition here. And then to print, I went out of the for loop. If we try this, no. Yeah, so we have the total number is equal to 5. And we can see that the people that have greater than 50 are 1, 2, 3, 4, and 5. So this is the first one. We can add up the score of only passing students, which means that after doing this, we can add up the score. To add up the score, we are going to follow the same pattern. So we are going to initialize the variable that is going to keep the total. We can add up. I think add up to score. Add up score. Okay. You will forgive me for the naming. So this is a total score. Let's just say okay. Student pass. So we are going to initialize it to 0 in a way that we are going to do the same thing here. And we come inside the if condition, and we are going to do the same thing equal plus. But the thing here, we are not going to do +1 because we are going to do the total of scores. So it's going to be plus student score here. So what is going to happen here is that if it's greater than 50, the add up score student pass is going to be equal to the current value plus the current student score. So we can as well print the total result here. Okay, and this is the total score. So if you run this, you are going to have the total number of students, but successful student is 5, and the total score of successful students is 373. So in short, for each and every iteration, we can even what can we do here to understand? I think you understand what I mean by this. Huh? So this, for the first iteration, it was 0. Student pass was 0 and add up score was 0. So every time student pass is updated, the student score is also updated with, not with 1, but with the current student score that is stored here. So I think for this one, I don't know if you have any question. We can even what can we do? Okay, I think this is the exercise number 3, and exercise number do we have this push-up? The population.
No, we have some other exercises before 3. Maybe we can first do those.
Okay. This is the population data. As you can see, we have excuse me, we have Nigeria with this number, we have Ethiopia with this number, we have Rwanda with this number, and we have Seychelles with this number. Are these numbers? The population is this. So loop over the dictionary with for country. Okay. So and print each country with a label. Large if population greater than 100 million. Medium if it's greater than 10 million. Otherwise small. So this is something easy. So we start with the for loop, because the for loop is going to put everything together. Okay. So I just want to know if are these numbers or
Okay. You can store them as text.
those are text. Those are text.
Yeah, because if try to print population we see.
Print populations. Okay. I think that
Okay, if it works, you can you can continue with that.
okay. Apparently these are numbers. Because I was a little bit confused with the underscore. So for country in for country, they say the for country pop in populations dot items. Okay, this is the entrance of the for loop. So they ask if print each country with a label large if the population. Okay, if first of all if pop is greater than 100 million. Let's just do what it. No, this is 100 million. It's going to print something, and then because there are many ifs, we are going to create something we are going to create a cascade of a nested if. We are going to create a nested if. So if it's greater, we need to print something. If pop. So is greater than wait, is greater than 10 million. Is greater than 10 million. Then let's try first. 1, 2, 3. It's going to print it again. We're going to come to that. And then we have the else print. And this is going to be the last one. So here we have a 3 print. We have a 3 if condition. If the country has a population greater than 100, you have to print 100 million. So okay, so here we are supposed to print for example, we start first of all with pop, no, country, with population, pop is considered as large. So which means that if this is true, it's going to print this country is considered as large. Save score, finish without help, mastered, okay. So this is the first print. The second print, it's going to print the same thing, but here it's going to be medium. And the last one, it's going to print as small. Let's try this and see if it's going to give us. Oh, we have an error. That items for country in population items. Oh.
Can you read the error?
Build function not iterable. It's not iterable.
Yeah, you know what I mean?
Mm-hmm.
Trying to iterate in that dictionary, but you've used a word, pop, which is a keyword in Python. You remember pop? Pop does remove something in a list.
Oh, okay.
Trying to use method.
Something else?
Yeah, use something else. You can add some, like pops, yeah.
Oops, okay. Yeah, those are keywords. Huh?
Yeah, that's a keyword.
Yeah, I also used the same pop, but it works. On the for loop, populations.items, you forgot parentheses.
Population.items.
Yeah,
Here.
For loop, yes. That.
Okay. Okay. Thank you. Let's print this. Yeah. So we have, we have 4 countries, and they are listed as such. So, yes, this is the result. Yeah. And yes, I think any questions so far? Yeah, I think we are good. Back to you, Dan. Thank you.
Yeah, I think there are exercises before that. There is exercise if you go up, but they are simple. If we've done these ones, yeah, we have exercise 3, 2, and 1. Go up in the if, yeah, yes, down. Exercise 1. Maybe can someone else maybe volunteer, because if he's done the bigger ones, these are easier. Anyone else?
Yes, thank you.
You can also keep sharing the screen and maybe someone dictates to you what we do, so that because I've seen you already understand all these things. Fiona, are you there? Fiona, are
I
you in
am there.
hiding mode?
I am
I think
there,
you're in
but
hiding mode. Nah, okay.
I'm in hiding
Because you do
mode.
not have a computer, you can. Sorry, you're not set up with this yet. You can help him finish the first, second, and third exercises. Is that possible?
Mm, hmm, Not
It's
sure.
okay.
Can I pass?
Hmm?
Can I pass? Because when someone else is doing it seems easy until you've practiced for yourself. I
Correct.
don't want to embarrass myself.
No, you're in a safe room. There is no embarrassment here. You can try, then you say he knows what we're trying to do. He will be covering you up. We're also closing our eyes. We won't see what you're doing.
Now let him continue, and we shall just fill in.
Okay.
I don't know, maybe someone else is willing to go. I don't.
Anyone? Maybe who can there share their screen?
Okay. I will just. I think they are not
Okay, you can complete it, Bob. You can complete it.
complicated. Okay. So we have. The if condition here. We have the if. Normally, even in normal life, we usually say if else. So it means that we have two choices. But here we have another option to say if else, which means that we have three options. And here in the if condition, you can see that the temperature, first of all, the variable temperature is equal to 24. And the condition is that if the temperature is greater than 30, it's going to be a hot day. If the condition is greater than 20, it's going to be a warm day. And if the otherwise, it's going to be a cool day. As you can see, for example, here the temperature is equal to 24, and you can see that here in the exercise they say NB indentation, the 4 space is required. What does it mean? It means that this space here is called the indentation. In a way that the indentation, when you create the indentation, it means that this particular thing inside here belongs to the main, whatever is written there. I think that this is something that you understand the indentation. So when you run this for 24, it's going to give you that it's going to be a warm day. Why? Because the 24 is going to come first here and check if it's going to satisfy this condition. because 24 is not greater than 30, it's going to go down to the second one here to check. If it's greater than 20, then it's going to print this and leave the if loop, the if condition. If, for example, we put 32, I think it's going just to stop here. It's going to say that it is a hot day, to print a hot day, and then leave the if loop. If we do 8 degrees, it's going to come first of all in the first one here. If it fails, it will go to the second one, and if it fails, it's going to print the last one. So this is in short how the if condition works. So going to this exercise, we have a student exam score. The student exam score is stored in score. So we have a score here already in place. Score is equal to 85. So the question is to know if the student either passed as a distinction, which means it is if score is greater than 80, if it is passed, if the score is greater than 50, and if it fails otherwise. So without taking too much time, I'm just going to, because we have 3 conditions, I'm just going to copy this and refactor it. All right, just to type it. So we have the first if condition here. If score greater than 80, the first condition, print distinction. Okay, but because distinction is because distinction is a literal, I mean a string, we are going to put it between double quotes. So the second condition, we are going to use L if score is greater than 50. This also can work. Is greater than 50. Is greater than 50. If it's greater than 50, you print pass. And the third one, else, which means whatever else that you have must be fail. Yeah. So we have this one here. Now let's see first of all if it works. Or because it's 85, it's distinction. Let's try 62 and see. 62 is supposed to be pass, and 40 is supposed to be fail. As you can see, yeah. And let's leave it 85. Okay, for the second one here.
Bob, what if I have 80?
80.
Yeah.
If you have 80, because it's not greater than or equal, which means that you are going to have passed. You are going to pass. Yeah. It's going to be pass. Yeah. Yeah, because we don't have greater than or equal to 80.
We have it. It's 8. That's correct. Greater than or equal to 80.
If yeah, they say if it's 80 or more, which means that we should put 80 like this.
Yeah.
Is 50 or let's do this here. Thank you for this. So this is supposed to be the right logic. Huh?
A question.
Yes.
You see in the question. Go back to the question.
This
You
one?
see the pass. If the score is 50 to 79, so
Yeah.
279. Does it mean anything that we can add in this?
Yeah, it's something that you can add. It's something that you can add, but it's not necessarily important here, as far as I understand. You can put something score in this, and you add the end, I guess, and score is less than something like that.
Or equal, maybe.
Yeah, less. Yeah, something like that. But I don't think that this can. Let's try. Yeah, that's it can work as well. Um, 28. Yeah, this can work, but it's not. This part here is already included here. You see, because whatever is below this is captured here. But even this is also something that we can use. Yeah.
Yeah, sure.
Yeah. But thank you for this. It can give more clarification. So I think this here we have the and and the or. You can see that and means both must be true, and or at least one must be true. Yeah. I don't know if you understand this concept. We're going to see it here. We have age equal to 25 as ID equal to true. If age is greater than 18, as you can see here, we have those and or. We have the end that we use here because this condition and this condition must be true. This is why we put and here. But when it's or, it means that one of them, if one of them is true, we consider the whole thing as true. Yeah. Let's give an example. I don't know. Okay. If age is greater than 18, greater than or equal to 18, and has ID, they say you can register to vote. Okay. Otherwise, if one of them is wrong, it means that everything is wrong. In short, yeah. So if you run this, you are going to see that this person can register. But when you put 17 and has ID, true, so which means that this person is 17 and he has ID. If you run this, they say that it cannot vote. Why? Because one of the two is wrong. Because when you use the and, both must be true for it to print the right result. If one of them is wrong, it means that the whole thing is wrong. And if we put, for example, 25, and we put false here, is 25 is supposed to vote, but because he has no ID, he cannot vote as well. So this is the thing with the and. So for and, both must be true too, for this to be printed. And for or, at least one must be true. If we put, for example, or here, let's say if we put or here, it's going to be true because that person is greater than 18, but he has no ID. Because he is above 18, he can vote. So that's the difference between and or. So let's go back to the original design of the. Okay, so we come here. A clinic gives free malaria test if a patient has fever. Okay, fever equal to true, and is under 5, old or over. Okay. So here, write the if statement and test if age equal to 3, fever equal to true. Okay. So what we are going to do here, as you can see, we have two if condition. The first if condition is to test if the age of the person, and the second if condition, wait a minute. Yeah, let's see how it goes. Free, not free. It's true. Okay, so maybe you're going to help me here. If fever, if no, let's not. If age is greater than is less than 5, and or age is greater than 55, 65. That's the first if condition. I think, can we combine all of them? I want to know if we can do this, and fever equal to true. So I think that I want to know if we can do this, but let's just try. Let's try. We are going to find out. Yeah, let's try. We're going to find out if this can be done. Oh, wait. Oh, okay. Equal. Let's try. We're going to find out if this is, as you can see, the indentation is respected automatically. If age is, and you're supposed to print what, right? If supposed to test if statement, okay. Free print free medicine, free malaria test. Let's just do free else. You print not free. Let's see if this can work. Otherwise, we're going to create two ifs. But I think this can work. Okay. So are you sure? Okay, yeah. Let's put the key as 3. So this is the first statement here. Age equal to 3, and the kid as fever. As you can see, the age equal to 3, and the kids as fever. So for the second one, the age equal to 70, and it has fever. I think this is supposed to be true as well. Okay, it's free. And for the third one, age equal to 30. Apparently, it's not supposed to be 3. And so what is happening here? Here, first of all, we have to check two things here: the fever, and as you can see, the fever and the age. So those are the two conditions that we have to respect. This is why we put "and" here, because both must be true. But here for the age, I put it in a bracket because it's a different situation, the age must be less than 5 or greater than 5. I don't know if we remove it, it's going to succeed. Let's try. Not free. Let's put 70. Free. Let's put 3. I think this can work as well. And if we put a false like this. Oh, you see. Now, because the age is 3 and the fever is false, the medicine is 3. So if we put 65, it was supposed to be false, because there is no fever. So for 65, let's put 66, because it must be. It's not free. And if we put 30, for example, and you have no fever, not 3. If we put but 3 with no fever, why is it 3? So this is
put 70.
70, and the fever is going to be not free.
You see?
I think the problem is the age here. It must be in the bracket.
Exactly. And that is what we called a logical error. It's giving you an output, but the output is wrong because of the arrangement of your operations.
Yeah, as the teacher said, it's a logical error. So it's better to keep them in bracket in case things are very complicated like this. I think for this one, it's also straightforward. The for loop, we are going to loop for each country. We are going to print hello for that particular country. Let's see how it goes. So what is happening here? It's going to print for country in countries. So the first for loop will go to, and for the second one is going to take Uganda and print. It's going to take Kenya and print hello Kenya. And you will excuse me for the time, and I think we will finish it. For the second one, for I in a range up to 5, which means it is going to start from 0 to 4. It's going to print I. So what happens here is the fact that for each loop, I is taking a value. The value, I mean, for example, here country is taking a value that is here. Like when it's printing, it's taking the value, the first value for the first iteration. It's taking the second value for the second iteration. And it's the same with I here. It's going to start with 0, it's print 0. It will go with 1, it's print 1, and so on. So if you come to an exercise similar to that one, we are going to see that loop over the list 12, 45, 7, 80, 9, 23, and print each number. Yes, a question?
Yeah, Bobo, I would suggest, because we already, over time, they can try it by themselves, because we've already done almost everything.
Fantastic.
Yeah, and please try those exercises.
Yeah. Am I supposed to paste it?
I think you don't need to do. We can try and as well, because you can say I already added the what you expect. Then when the answers, you can just run and check whether they meet. You can see there, done when part 1 prints 5 numbers, part 2 prints 10 numbers, ending at 30. So you can use that for testing.
Fantastic. Thank you very much.
Yeah, thank you very much, Bobo. And as you can see, the push-ups are push-upping, right? So please, we don't want to leave anyone behind. Next week, mushonje muhishiwe, you should expect, I'm whetting your appetite, you should expect a lot, and we'll cover more advanced stuff called functions. Instead of running things.
Sorry.
Yes.
So I want to download this the Python. How do I do it? Like briefly, I've been trying to do it and it takes me to GIT